You're doing the victories computations, or not necessarily that one because it's kind of a silly example, but in general when you're dividing units by units, keep track of what units you have. A lot of folks were dividing correctly something by something and getting like 0.7 and thinking that was 70 seconds. That's 0.7 minutes, which then becomes something like, I don't know, 42 seconds or something like that. So just make sure you realize, and that's one of those things where if you think about your answer, and think about if it actually took me, whatever it was, 70 seconds to run a victory, could I have done 12 of them in 15 minutes? And you realize real quick, I run out of time. I wouldn't have 15 minutes to do that. So that's, and this is, again, in my opinion, this is one of the downfalls of modern mathematical education is we ignore the dimensional analysis. We ignore the, does that answer even make sense kind of thing. We get to a number, we spit the number out, and we never stop to think, does that number even make sense? And then the next thing you know, we are fed news media results when they're spending $500 billion on this and $2 trillion on this, and we let it go right over our heads, not realizing that $2 trillion versus 500 billion is the egregious 2,000 times bigger than we realize it is. So it's one of those things, just being cognizant of that. But I'm nitpicking at this point. There were very, very few of those errors. The big ones, and I say big, not majority, not even close to majority, were just the little random, forgetting 2 standard deviations. That was one that kind of jumped out at me. Another one was just the interpretation of the standard deviation, making sure that it's an average distance from average. But again, I'm not trying to harp on negativity here. I guess I'm not trying to bring up negativity. You guys did great. I mean, fantastic on the results. My goal was to send a progress report out to you guys yesterday, and then yesterday evaporated. So I will do it today at some point in my office hours. I'll sit down and send you progress reports with everything I've gotten so far. Which will be everything up to that out-of-class exam. Yeah,
I had an issue with spreadsheets.
You had an issue with spreadsheet?
Yeah, on F&G, I haven't tried it yet.
Well, that's weird.
I put in exactly what you told me to do. It just put ones and there was nothing on the graph.
I'm guessing you didn't do it quite exactly.
I brought my computer to show you.
Well, that doesn't, there's the warning I've always given you about, do you have an Apple?
Yeah, no.
Okay, but there's the warning of compatibility. Because you guys all have access at work. Like if it's not working on your computer, just go to a computer lab and spend 10 minutes in computer lab.
Yeah, but I didn't. I'll explain that.
Well, that's what I'm saying. Like, yeah, we can figure out the break. But the idea of that, I've given up trying to understand computer manufacturers because they sometimes want to give you a good product, but they always want to make money. So, and sometimes the second is more important than the first to them. So then we get the compatibility issue. So I've given up trying to understand them, so I just say, you know what, you all have Excel at work or at school, just use it there if it's not working. Because I can't, I have all this gray hair, 80% of it's from my son. 20% of it is from that kind of stuff. Just trying to understand why Bill Gates can't play well with Apple. So, yeah, anyway. Cool? All right, was there a quiz due today?
Yeah.
Good. Was it just one or was it 2? One, okay. All right. I promised you guys a second one. I never got around to making it.
Okay, you can do next week.
I will. I am going to make it. It's written on my desk to do for next week. And there's already one posted, except it's not posted for next week. Usually by now I like to have them posted. There's a quiz due text on the schedule page, but it's not hyperlinked yet. Because that was supposed to be done yesterday too. Did anybody go to the math open house yesterday?
The what?
The math open house at Grandview.
Oh, is that where Michael's doing the math local club thing?
No, that's something different.
Okay.
That's something different. So none of you went, right? Thus reaffirming my point, we shouldn't have done it. Because the reason I got nothing done yesterday was because I was up at 3 in the morning prepping for this math open house that I think 10 people went to. I think. Right? Even though I told them, you might not want to do this, it's Grandview Hall. Grandview Hall is up there, very, very far away from everything except the dorm. And the dorm I don't even think knows it's there, because when the kids walk out of the dorm in the morning, they're half asleep. So, anyway, my apologies for not getting stuff updated. I didn't get class updated from Monday. I apologize for that. The videos weren't up. They're on YouTube, but they didn't get linked because I didn't even have 20 minutes to myself yesterday to sit down and do that. It'll all get done, and I'm thinking around 1 o'clock this afternoon when I get back. So, just frazzle fried right now with all that crap. So I apologize for not being as kind of regular as I have been. We'll get back to it, though. We'll get back to it, I promise. I got in here at 4 a.m. and got all the math puzzles up on all the boards, and then video recorded everything and got that on YouTube as well. Except I didn't link that either; it's just uploaded. So video, pretty much I was a tech guy, math problem guy. So, find the next element of the series, how many triangles. I can read your mind. Here, try this one. I can read your mind. There you go. I can read your mind. Think of a whole number from 1 to 9. Don't tell me, just think of it in your head. A whole number from 1 to 9. Okay? Multiply it by 9. Okay. Add the digits of the number you now have. You probably have a 2-digit number. Add those together. Okay. Point that thing at me. Subtract 3. Add 1 if you have blue eyes. All right. So now you have a 1-digit number in your head. Find the corresponding letter of the alphabet that goes with that number. So if your number is 1, it's A, 2, B, 3, C. So whatever that letter of the alphabet it would be. Okay. Got that letter in your mind? Okay. Think of one of the United States that starts with that letter. Okay? Think of a color that starts with the third letter of that state's name. Think of a fruit that starts with the last letter of that state's name. And I bet you thought of an orange apple.
Hey, what is wrong with you? That was awesome.
Ha! Orange apple. It's great. I had that whole thing written on the board and I had a picture of an orange apple tacked to the wall. I said, how did I do? We picked the picture up. You're like, holy crap, you read my mind. It's not magic. Anybody figured out how it worked? I made you all think of a number, multiply it by 9, and add the digits. At that point, all of you had number 9. Because that's the cool thing about the 9 times tables, the results always sum to 9. 18, 27, 36, 45, 54, it's the product. Then I said subtract 3, so now you all have 6. I said add 1 if you have blue eyes, so you either stay at 6 or 7. Some of you had 6s, some of you had 7s. I said think of a letter, so then you either had F or G. You had Florida or Georgia for the state. Florida, O, third letter. Georgia, O, third letter. Last letter A for both of them. When I say think of a color that starts with O, unless you think of olive or something like that, you're going to think of orange. An apple that starts with, or a fruit that starts with A, chances are you're not going to say avocado, which I don't think is a fruit anyway. So, it is. Oh, it is. Man, it is a fruit. But chances are you didn't think about, anybody think of avocado? Got some outliers in here? Okay. It's got a C, that's what makes it a fruit. Zucchini's a fruit. Such a weird definition. It reminds me of a saying I once heard. Knowledge is knowing a tomato is a fruit. Wisdom is not putting it in a fruit salad. I always like that. Difference between intelligence and wisdom. So. Anyway, so I got done doing things like that which nobody saw. I think the only 30 people on campus that know that are you. So I appreciate the fact that you guys said it. So today, you guys did your corrections for your exam. How was that? Was that good? Was that worthwhile? Worth your time? Yes? Yes, of course. Go back and look at things. Did you look at anything and go like, oh God, I knew that? Of course you did. Of course you did, because you did. And that's the reason the rainy day is nice, because it lets you go back and do just that. It lets you go back, look at it again, and say, oh, I totally could have done that. I hadn't had enough time. Well, there you go. Now you've got a little more time to do it. So, yeah.
I'm hoping you'll be nice about this. I forgot to actually print the rating day.
Well, then go print it and bring it back to me.
Is that okay?
Yes.
Okay.
I know it doesn't say print the coupon on the thing, but it does say attach it to the exam and hand it in. So maybe I should put the word print on. No, it's okay. It's okay. And being the hippie that I am, you might think that I wouldn't want that. But there's something about the physical do this, attach it all and submit it that seems to work better than not doing that. Like believe it or not, I've actually looked at this anecdotally. I get better results when I make you do all this than when I just have you do corrections on the sheet and hand it back in. Because I think it's easier to do the A, B, compare, contrast. And the coupon is just something like about being American. We like coupons. For some reason, it's like an American thing. I don't know. It just seems to be like a cultural thing. Yeah? So good. Anything from relative position give you guys grief? I want to build on this today for sure, and I've got to run back up because I have an in-class quiz for us to do. I don't have those to get back to you. Again, Amber will get the in-class quizzes you guys did last time, the great little sampling quizzes you guys did. I'm sure nobody attends on them because you filled in the 5 spaces. But we'll get those back to you too ASAP. I'm guessing Monday.
What in-class quiz?
The beautiful in-class quiz we did last time. We do so much in here. I'm sorry. It's hard to keep track. And if you had seen the video, you would have known it. But you couldn't see the video because I didn't upload the damn thing until last night.
Which I did look for on Tuesday.
You did look for it?
Yeah.
I know! And I know you guys are doing that. That's what pisses me off. Because I know you're doing it, and I can't get the 20 minutes. I need 20 minutes is all I need. 20 minutes. to actually just put in 243 WM, 243 WM, 243 WM, fall 13. That's all I got to do, and then put the link on the schedule.
Can I just say, it's totally awesome that you do that.
Yes.
But the thing is it's my pleasure to do it. I want to have that resource there for you guys. But then when that happens, I'm like, what am I doing? My students now don't have a resource, and people that aren't even showing up get a resource. That's like the ass backwardsness. It's how our government works in a lot of ways. You know, you create these things that benefit 1% of 1% while 99% suffer. It doesn't make any sense. Woo! But you're here now. I'll get the damn videos uploaded for you as soon as I can. Anything in here give you grief. There are some video links onto this. Hopefully they helped if you needed them. Looks like I put some videos in there. Yeah, I got some thrown in there. Anything give you grief? Relative position? Box plots, quartiles, percentiles in the news down there, credit cards, how undergraduate students use credit cards, please, Danny.
I'm having a little trouble finding percentiles. Like,
No
I don't
problem.
understand the math
Let's take a look.
correctly.
Let's take a look at one. Which one? Which one you want to look at? 212?
I think I had the same problem.
No problem.
Write it down.
And now here's the deal.
Any of them are-
EUS rule. Thank you for that question. Let's take a look at it real quick. Let's get the textbook. All right. Pat, you have the same question. Good for you.
I think so.
212 number 3. Try them all again. Good review. This guy right here.
Or like 213, 1 J and K. Or
1 J and K, 87 to 100. Okay, let's go right to that. Which one are we looking at? We're looking at 1 J and K. Oh, this guy right here. Perfect. Perfect. Okay. So.
Yeah.
Great. And I think part of the thing too is because statistics is created by people, there's different interpretations. I mentioned in class, this would have been about a week ago now, when we looked at Max and his weight data with his second-year checkup. Percentiles aren't always measured the same way. Sometimes there's a 0th percentile, sometimes there's not. Sometimes a 95th percentile in one data set will be a 99th percentile in another. So I told you guys just to think about percentiles, just think about them as the percent that you exceed. So let's come into this. 25 randomly selected students were asked the number of movies they watched the previous week. Results are as follows. Here we go. Beautiful. Do you want to complete this whole thing?
No.
It says to complete the columns of the chart. Was that part of what you had to do?
No.
Okay, you didn't? Okay. Then let's not. Let's just use, what if I can just use this? Yeah, this will totally work. Okay, so J and K, the 40th and 90th percentiles. Okay, so there's 25 kids in the chart, correct? So I'm thinking this sums to 25. Guessing that's what that means. Let's check it. Yes, we're good. So what we have to figure out is, we've got a series of numbers. Now we can do this within the chart if you want to, or we can do it with the laundry list of values. Let's try it both ways. Maybe we'll not like one way, but like another way. You know what? Actually, let's go in the reverse. Let's write these 25 numbers out and start there. Let's and then go back to the chart and see if we can extrapolate. See if we can extrapolate. So number of movies 0 seen by 5 kids. That means we're going to have 5 zeros at the bottom of our laundry list. 9 kids saw 1. Okay. 6 kids saw 2. 4 kids saw 3. And 1 kid saw 4.
Forgot a 43.
What did I forget? I'm sorry.
3 3.
Oh, 4 threes. Sorry, 4 threes. Thank you, guys. Good. Yay. All right. Sweet. So, we can find the median pretty quickly now. I mean, you can find the median pretty quickly in the chart, too. But finding the median, you just have to find where.
Equilibrium balance.
Exactly. Well, balance from left to right geographically. So I guess it would be the 12th point in. That would be your median. I think that's one of the the quartiles. So let's find the quartiles and the median for starters, and then work backwards to find, because you guys are asking for the 40th and 90th percentiles, right? Okay. So let's find the median and the quartiles for starters. We'll do them in blue. So the median would be 12 in. Well, actually 13 in, I guess, right? Because 25 of them. 13. So here's your median. Did it bother anybody that I came down from the top? Does it matter? No, because it's 13 down or 13 up as long as they're in order. So there's your median. And here's your median, by definition. And again, I can't emphasize this point enough. That's what we call the median. The median is just defined to be that middle point, or the average of the two middle points if there are two of them. Cool so far? So what does that tell us? The median is 1, therefore,
50%.
oh, 50th percentile. Good, good. That's the 50th percentile. Which means also what?
Quarter is half that, right?
A quarter is half of that. Good. So the quartile will be the median of that lower half, and the other quartile will be the upper half. Thank you, LaWanda. Absolutely. You're getting one step ahead of this. We'll get back to that. Just give me like 30 seconds or so. What does that actually mean? And you're also, in verbalizing what the 50th percentile is, you're seeing one of the limitations of it. Go ahead, John.
Less than 50% of the people seen 1 or 0 movies.
Right. Here's the problem with it. Technically speaking, the 50th percentile is the cutoff between the lower half and the upper half of the data, meaning people to the left saw fewer movies, people to the right saw more. The problem with this data set, and this is just a function of the function of the median, is that there's a bunch of 1s that are below that 1, aren't there? So yeah, by definition, half of the data points are below the median. But some of those data points are equal to the median. So that does create a bit of a mental confusion for us, and that's okay. That has to happen. That has to happen. I mean, technically speaking, the median, by definition, is where half the data points are below and half the data points are above. But one of the data points above it is actually equal to it, and a whole bunch that are below it are equal to it. That's okay. That doesn't change the definition of the median. It just makes it a little bit confusing when you think about the idea of a percentile ranking when tied to the median. Okay. How about the quartiles? We'll want to ask for that. Let's find the quartiles. So here are 12 data points, yeah? So I'm thinking we got to go 6 up and 6 in, and look what happens. Isn't that also 1? Isn't that going to be 1 as well? Hence, one of the goofy things that sometimes happens on small data sets with kind of low variability. Your lower quartile is also 1. So if we did a box plot for this, which I think we're going to have to do now that we've seen the interestingness of it, try to predict what the box plot's going to look like. Ooh, it's going to be a good one. It's going to be a good one. Let's find the quartiles. Another quartile. So that's going to be halfway this way, right? So 2, 3, 4, 5, 6. 6. There's Q2. Q2 is 2. Q3. That's not Q2, that's Q3. I'm sorry.
There you go.
Thank you. Call that out when I screw them up, Andrea. So the second quartile is 1, the median. So you got an idea what that box plot's going to look like when we draw it? Yeah, it's going to look interesting. It's going to look interesting. Say that again.
1 and 2.
Good, good. What's it going to appear to be missing? Good, the median, oh, you're right, I call it the average, it's fine. The median line will appear to be missing when it's not really missing, it's just sitting on top of Q1. Good, good, good. But, we're not here to talk about that. Are we? We're here to find the 40th and 90th percentiles. Where are they going to be? Now, you could probably use a formula for this. I don't want you to. I want you to think about what the 40th percentile means. What does it mean? 2/5. Tell me more, Renee. That's all you guys, I just got 2/5. Actually, 2/5 is good. And a snort to go on, that was even better. John, go. It was fantastic. I love snorts. Go.
In the first quartile, it's 1, and the median's 50th percentile, it's 1. So you know that 40% is going to be a 1.
That's a perfectly logical way of looking at this particular data set. Did you hear what John said? He said since the median, which is the 50th percentile, is 1, and the lower quartile, which is the 25th percentile, is 1, and the data are in order, the 40th has to be somewhere between 25% and 50%, 0.4, 40%. So it has to be 1. Thank you. That's a perfect way of looking at it. But how can we look at it in general, not just for this data set? Thank you, John, for this. That's perfect for this one. Think about what Renee said with 2/5. That's huge. What does the 2/5 mean?
To go 2/5 into it, so if you have however many points divided by 5, multiplied by 2.
Boom! Think about this. There are 25 data points. Every 5 data points you go is 20% of that, isn't it? So here's 20% of the data points right here. Here's 20% more. Here's 20% more. Here's 20% more. Here's the final 20%. The divisors between those would be the 20th percentile markers. Does that make sense? So let's mark them up. Let's mark those up. Shoot. Here's P20. So it would be 0.5, wouldn't it? Between 0 and 1 would be a half. So there's P20. Let's go 5 more. There's P40. Look, we agree with John. Perfectly. It's got to be 1 because it's between two 1s. There's your 2/5, Renee. Perfectly. P60. Let's go 5 more. 1, 2, 3, 4, 5. Here's P60. Cool. And then P80 would be the next one. 1, 2, 3, 4, 5. So that'd be 2.5, wouldn't it? That'd be 80. Fair enough? Yeah, that's nice. That's nice. That's good. Now, I'm sure there's a formula somewhere you can use, but why? Just do this. I mean, like, did you hear what Christina said? She took Renee's 2/5 and said, well, then just take the data set, however many there are, divide it by 5, and then multiply that by 2, and then go up that far. So we just did that, didn't we? We did the whole data set, divided it by 5 to get 5, multiplied by 2, went up 10. And there we are, 10. But we kind of go between the two of them. Now, if anybody goes to this point and calls it that, totally fine. Anybody goes to that point and calls it that, totally fine. Anybody comes out to here and calls it 2, totally fine. Calls it 3, totally fine. In general, as long as you're close to 80%, I'm happy because no two people on earth agree on what a percentile rank is anyway. I would get, is that what you're going to say, John?
No, I was just thinking that we still got to split the final 20%.
We do, don't we?
Yeah.
Because the last one was a 90th percentile, wasn't it? So where's that going to be?
3.
Well, it's got to have to be this guy, I'm thinking.
Yep.
Because here's 80, here's everybody. Between that's going to be your 90. So there's your 90th percentile right there. Yeah. And you can split it, but these are all 3s anyway. Now, John, to keep with being general, which I think you hit at something very, very intuitive and beautiful back there when you said, well, if that's 1 and that's 1, this has to be 1. It's perfect. These generally are all going to have different values or slightly different values. So in other words, if you come up here and you call this the 90th percentile, or if you call this one the 90th percentile, or that one the 90th percentile, in my opinion, that's all the same thing, because you're ballpark where you are. If you need more precision, we'll have tools we'll develop later in the class for more precision. Here's the idea I'm looking at. Every one of these data points represents how much of a percentage of the overall data set. How much of a percent is that particular point? It's 4, isn't it, Danny? It's 4 percentage points. So every time you add up 4%, 8%, 12%, 16%, 20%, now you're up to 20. 24, 28, 32. See, you can use a formula for this, but I'd rather you not. I'd rather you just kind of go with intuition with what it means. And think of Max, 80th percentile because he's bigger than 80%. And that's why I don't care if you put the dotted line here, here, here. Slightly between, that's totally fine too, splitting hairs, split in between. As long as you get close to what percentage we're talking about, that's what I'm looking at. And when I mean close, I mean close. I'm not trying to define that. I'm talking about if you're fewer than 2%. Because 2% might mean different things in different size data sets. You could be off by 8% here and I'd be happy, because each of these is 4%, right? So if you put that 3 versus that 3, that's an 8% difference. But as long as you're not putting that 1 for the 90th percentile, that's when I get nervous. The biggest error I see with this, just FYI, and I almost hesitate to say it, because sometimes when I say it's kind of like mountain biking, like don't look where you don't want to go. A couple of mountain bikers laughing. Is people forget to sort the data before they start scanning it. Like you actually don't, you look at the data in a raw scattered form, and then just start counting from the bottom. Well, it only works because they're ordered. And that's why the histogram was actually, or the distribution was nice from the beginning. Could we have done this from the original distribution? Could we have done it from this without having to write it out like that?
Yeah.
Totally. Totally. You've got 5 data points up from the bottom. Now you have to know this, because you have to get Renee and Christina's 2/5 going. So you have to know that 5 25ths is 20%. So your 20th percentile is going to split the 0 and the 1. And then you pick up 9 more. Now you're at 14 25ths, which is too big for the 40th percentile, isn't it? Because now you're at the, if you add all those up, you're at 14 25ths, which is like 56%. So now you're above 40. So you've got to drop back to get the 40. So 40 must be in here. Is that fair? It might seem like magic, but it's not. It's just simply counting. and adding up those percentages. And I don't want to harp on a formula. I just want you to think of it intuitively like that. If that makes, hopefully that makes sense. Please, Katie.
How, I'm kind of confused on how you got the 4%.
Oh, because there's 25 data points. If that represents 100% of the data, and each one counts equally, as it does in the median. That's the thing about the median. Every data point counts as one data point. Not for its size, but just the fact that it's there. So each one is an equal piece of 100. And if there are 25 equal pieces that make up 100, they have to be 4 each. There's your 4.
1/25 times 4.
Yeah, there you go. 1/25 times 100. So 1 over n times 100. If you want a formula, I'll say you want a formula. That's okay. 1 over n times 100 gives you the percentage each one is worth.
So just 1/3
Yes, times 100. Or just 1 divided by 25, 0.04 is 4%, that works too. Yeah, so if you want a formula, what you guys are actually doing right now is you're developing the percentile rank formula in your minds. Here, 1 over n times 100 times k, which is how many are down there. Oh God, I just said it out loud. Sorry. I know, but that's, if you want a formula, there it is. But honestly, I think it makes more sense to go to holistically, so you're not doing that. Jared, please.
You could just do 100 divided by 25.
You could, which is the same as 1 over n times 100. But yeah, 100 divided by 25, that's even cleaner. 100 divided by n. Boom. That's good. Times k, which would be the ones below. All right, yeah, I guess times k. Yeah, k would be the ones below. I don't know why I'm calling it k, but I am. So 100 divided by 25 times how many there are below tells you your percentile rank. Hopefully that makes sense. Because the times k would add the 4s that many times. 4 plus 4 plus 4 plus 4 plus. You didn't like that. We'll stop with that. I don't like formulas either, for the most part, with statistics, because they tend to get in the way more than show things. I don't know if anybody got a chance to watch. I put some videos up on Sunday for some older homeworks explaining variation, and some of them were done algebraically, some of them were done with Excel. And as I watched the algebraic ones, I'm like, man, that's pretty. And then I realized that you don't think that, I'm guessing. You're probably like, wow, x bars and x sub 1s and x sub 2s, that looks like noise to me. And that's the difference between like coming at it from a math point of view and coming at it holistically from a statistical point of view. This is way more commonsensical than trying to force a relationship onto it. So, and please realize I accept the variation in your answers because of that. I mean, like the median of this data is 1. Now, did anybody run this through their TIs to get that value? Good. Grab your TIs. Let's take a look at this. I want to look at this box plot, this bastard box plot. I do want to see it, for sure. Just because I'm curious now. Plug you in. That might help. Still talking. Well, yeah. It's only been 10 years. Because it knows I'll say hi. 20, 22, 23, 24, 28. What is that, and do I need it? Oh no, that's state data. We're done with that. So I'm just going to put the distribution in, the 0, 1, 2, 3, 4, 5, 9, 6, 4, 1. Yeah, we're doing all this stuff. Yay.
Wow.
Well, that data. That was just you guys. You guys in the other class of states data is all that was. All right. So let's just do a box plot, a histogram. We can kind of see what the histogram is going to look like already just by turning our heads sideways. Now you know what? What the hell? Let's do both. Histogram and a box plot. Why not? Why not? So plot 1, I'll make it be a histogram. L1, L2. Hopefully this is becoming. My hope is that by doing this enough, and we'll do it more in class today. We'll do it more in class today, the idea of looking at a histogram of data and identifying what the shape of the data is, because I really do care about that. It's important to know the shape of the data before blindly applying any kind of a measure on it. My 105s learned that today. I took my bike up to the top by Juniper Hall and stretched out a 200-foot tape and had them time me. I rode by them at 25-foot increments, and they were stopwatching me as I went by. And we had just been doing linear regression, which is take a bunch of data points and fit a line to the data. I said, cool, let's go find myself a linear model. And I put the times up on the chart, on Excel, and the dots did not go like that. They went like this. And I said, cool, linear regression. So I threw a linear model on there. And they kind of looked at it, they scratched their heads. They're like, but that's not a line. I'm like, so what? We can do a linear regression, right? And they're like, but it's not a line. And they were getting the point. The point is you should look at the data first, before you just do something to it. Does that make sense? You could put a line on that data. Should you? No, because it's parabolic. Because it's a force of gravity pulling me down that hill. Not some weird, strange, linear force that, like my legs or something. Anyway, there's that. There's that. Let's put the...
Whoa.
Oh, this is already set up for... You guys remember how to do the box plot?
No, I don't.
Well, we'll pick this up then. So it's set up the same way as the histogram, L1 and L2. L1 and L2, same way, except just pick the box plot instead. You may want to finagle the window, because I'm going to do a zoom 9, and it's probably going to lay it on top of itself. Yeah. Okay, there it is. You guys mind if I finagle a little bit to clean that up a little bit? Because right now there's a gap in the histogram which should not be there. There should be no gap. These are perfect. I'm seeing scrunched faces. I apologize for scrunched faces. You getting error, Shelby?
No, it just doesn't look like that.
It doesn't? Oh,
No.
check real quick. Second y equals. Make sure both of yours say L1 and L2.
Oh, it can be both, okay.
Well, you have to because your frequencies are in L2 and your data is in L1. If you don't have L2 on there, it probably is a rectangle that went straight across, isn't it? Which is a uniform distribution. We'll get back to that next week. Fair enough? All right, so let's take a look at this. Zoom 9, I'm going to finagle. We're going to make the x min 0. I'm going to make the x max 5. I know that sounds a little silly. I'll explain why in a minute. I'm going to make the x scale 1. I may need to finagle more. I'm going to do it right now. I'm going to make the y max 12. I'm almost positive I'm going to have to raise that a little bit more, maybe even. So this is all in the window screen, and this is just my guess as to what it should fit. Let's take a look. I had to do it more. I got to do it more. Make that y max 15.
No, just make your y min 0. And
Oh, did that fit it okay?
Yeah.
Because it takes it off the bottom. Thank you, Danny. Perfect. I forgot about that. I never look at the y min. I just thought leave it at negative, whatever it is. There we go. There's our goofy box plot that we said it was going to look like. Now, it's not that the median is not there. It's that the median is sitting on top of Q1. So if you press the trace button, if you press the trace button, it slaps you onto the histogram, and you can trace the histogram. But the histogram just tells you that what the frequency distribution you already put in was. If you pop up, hit the up arrow button, now you're on the box plot. And it tells you the min is 0, Q1 is 1, median's also 1, Q3 is 2, and your max is 4. Yeah. And we have an outlier in this data set, believe it or not. As weirdly, would anybody have said that the 4 was an outlier?
No.
No, because it just looks like a normal part of that curve. But by one definition of outliers, that is an outlier. Check this out. Change your box plot to the other kind. What's up, Katie?
mine keeps changing my window.
If you go to zoom 9 each time, it will. You have to hit, if you're messing with the window, you have to press graph.
What is that new thing? Oh, mark.
Yeah, the mark is where the outliers will be. And there is your outlier. Your 4 is actually an outlier, and we're going to talk about why today. There are certain mathematical definitions of outlier that are used, and one of them is based on the box plot. One of them is actually based on the box. It's kind of one of those happenstance kind of things where it's a construct. We're getting close to the part of the course. The back half of the course is probability. Probability is natural. It happens. Statistics is forced. We create measures that are human-made. As such, that's called an outlier by one construct of outlier. Matter of fact, we'll use this data set to introduce it. We'll show you both measures using this data set, and then we'll do a couple other data sets. But I want to make sure that this made sense first. We kind of ran through this we kind of did the entire homework problem. Apologies, but hopefully it made sense. Cool? Yeah, leave that data in your TI. We'll use this for an outlier definition discussion here in a minute, and then we'll also generate some of our own data sets. Anything else from the homework you want to look at? Let me ask a question, and this is, I'll re-ask this at the end of the term. Has anybody been using the homework video links at all, the ones where I work the problems? Are they helpful, or are they kind of like, I could do without them? Decent?
Yeah.
Decent, okay, good. I'll do them regardless, because it's part of the open source, it's kind of like my open source methodology is putting my part into it. But if it's helpful, that's just icing. Like on that pumpkin bar they had. That was one good thing about that at open house yesterday, they had pumpkin bars. Somebody made pumpkin bars with like some kind of cream and cheese topping. Sweet Jesus. I snorted it quite a bit. It was wonderful. Delicious. Many times. It was awesome.
How many
Might do it
victories
again.
are you gonna have to do to?
How many victories? Well, I did yesterday. Jenny almost killed me, so I paid for those.
I wasn't expecting.
I've never been that hypoxic in a while.
I don't feel so great.
I've never fallen down after a victory before. So victories are awesome. I saw from they're great. Wind sprints, they're ludicrous. She made us do a bunch yesterday, but then I was running against one of the fastest kids in the class, and I couldn't catch him. But I tried, because I'm 40, and I think I can still do that. And I actually crossed the 200-yard. It was a half-field victory, so you start in the middle of the field, and you have 2 turns as opposed to just 1. So you run 200 yards and you turn twice, which for me, for old guys, it's hard to get started again once you stop. And I came across the half field and I was seeing black dots. I could see Axel. I couldn't catch him. He's up there with the heart rate monitor. And I just fell over. Have you ever fallen over? They run so hard they've fallen over. I've never had that experience before. And I wanted to die for like 15 seconds. I was kind of hoping I would. Vomit, one of the two. Anyway. Cool? Cool. I think I'm here to tell you that today, though. Anything else? Go back to the homework sheet real quick. Oh. There we go. Anything in here give you grief? Hopefully there's some solutions. There's some box plots to compare down there. Give you some answers. That's good, too. We good? All right. Let's take 5. That's a good place to break. Leave that data in your TI. We'll come back and use that next. Because I want to talk about this idea of an outlier. Good. I'm feeling better. That's what it was. I knew it was. Oh, why this is not working? Sure. Let me see. Oh, big screen. I lived in a room smaller than that.
Oh, I
So that's space being required.
Okay, so I tried to do a bunch of things. I want my head back. It's definitely on the end of it.
Yeah, okay. Oh, okay, you can just minimize that.
My head gained
So then you
5
grab
pounds.
you grab right off.
I was smell like grab it and drag it.
What were you trying to make?
I was just trying to put it in the other end. Like I just think
No, if you look at that, I say drag it until it's in the other end.
No, it does not say that.
Something like that. It might not say exactly that.
We're like, I'll tell you
Like, I'm from Michigan.
Christina,
Call down.
what you got? What you got?
Right before I have this business, I work out.
Oh, is this why not where?
I can't do
Give or take it in. What is give or take? Oh, no. And I in your mind, you know what give or take means, but I want to make sure
I know that I had to get
quantify the definition.
for my
Give or take.
Oh, I wonder what.
What does that mean?
No, and I don't know who's gonna be there, but like the sisters guys are gonna be there, and they'll probably know who he is. Okay.
I basically just made this
I'm gonna get green
On average. So that's what I needed to see. I needed you to use the X bar right here. And the value of 1. If you give or take 1, is that on average? 1 or 1 egg away from average. So the give or take, and it's so easy to call it give or take. I'm sure we've said it here too. But as far as like a formal definition, that's what that makes sense.
Yeah, absolutely.
Good. Now the why not where? Oh, you know what? I do, because I realize this. I thought about that. Why are some it means and I realized when you go to replace price inflation, I should have taken 3 points off. It was worth 3 points. You told me that application, so you partially answered the question, but I wasn't going to know why. So I only 2 of those points back. Tonight, like this, so I myself, back to you on Mondays, okay?
Yeah.
No, I'm glad you said. I will give this my praise. I'll give you 2 points back. It was one of those ones I was grading too harshly before I realized I'm like, it's just part of the answer to the question, but they're not telling me why it's used there. And the reason I was looking for it was that in supervised inflation, there are some periodic displays of drops. Those should be calculated to the average because they pull the average. So you pull those off. So that's what I was looking for. I'll give you that. Thanks for making sense. That's for me to remind myself, and I'll put it in the pile of this. I think that's a part of this. I didn't bring it with me, Christine. Did you have time at like 12:30? Between 12:30 and 6. It's up there in my pile. I didn't grab it. Oh, no, sure. And we'll get to it for sure. It's okay. I should have found that. I told Catholic school I should know better. That's the means.
Thank you. Have you ever lost it?
Oh, that was the interpretation of standard deviation. It's not. Well, here, what is standard deviation? What are you really doing in that formula? We're figuring out how far the data points are from the average, on average. That's what it is. We're figuring out how far away they are from the center, and then averaging those distances. That's what I was looking for. Is that fair? Makes it? Well, it is. But it was there. I just didn't see it. But now we know though. I just said something. Watch it. This is not equal 0 is not. That must be yes. Oh, thank you. See, Taylor almost down to the thing. I didn't even bother looking. It just says fix it. Thank you. I will remember those things.
So, I'm not really happy with the like,
Okay. I want to refrain from answering. The guy that rides his bike up